Hello, welcome back to this video 3B-6, and this is part 2. We are going to go ahead and look at rewriting logarithms and answering questions involving logarithms, specifically for the multiple choice portion of the AP Precalculus exam. So, without further ado, remember that when you're talking about properties of logarithms, you need to have gone over these, so check a previous video if you need to, and then as well as how do we use these properties to change a logarithmic expression. So, these questions down here at the bottom of our notes, these are all listed as practice. So ideally, you just pause me and you can try these and we can go over the answers. But I'll just kind of go through these problems here. Okay, so let's just, without further ado, let's just jump in. The function f of x equals log base 10 of x is equivalent to the following. Well, remember, log base 10 of x, this is the common log. So it is common in order to go ahead and see this written as f of x equals log of x. So no base here. It would definitely not be b, right? That's log base e. And a uses change of base. This is similar to change of base, but notice that the x and the 10 are swapped. So they're trying to trick you. And then here they probably didn't have a good distractor, so they just threw that out there. All right, second practice problem here. Let a, b, and c be positive constants. Which of the following is equivalent to log base 9 of ac divided by b cubed? This is a very, very important problem. I would put a star next to this one. I have seen this type of question multiple times across multiple practice exams. This is the deconstruction of the properties that we just utilized. So it's really like working in reverse. So if you can kind of think about our previous problems, how we got to an expression that looks like this, you can kind of think about how this would look. So what I'm going to go ahead and do here is I'm going to kind of deconstruct this in pieces, right? So since I'm dividing, that indicates subtraction. So we have log base 9 of AC minus log base 9 of b to the power of 3. And then again, here I'm multiplying, so that's going to indicate addition, right? So this would be log base 9 of A plus log base 9 of C minus, and then that power of 3 there, that can come out front. That's the power property in reverse. So log base 9 of b. I would expect this to be the answer, or again, some form of this where these are commutative, right? So you could swap these. So let's go ahead and see. Yeah, it looks like it is A, the very, very first option here. A. It is not B, right, because they're subtracting. That wouldn't result in multiplication. Here I am adding, okay, and here I'm subtracting, but that's a power of 1/3. I see what they're kind of doing there. No, that would be wrong. Should be a 3 there. Okay, and then D, here they're just counting on you making the mistake that, yes, I'm adding, but it needs to have its own argument there. Okay. The function g is given by g of x equals log base 3 of x. Which of the following is equivalent to g of 5? Don't overthink these. These ones usually are pretty straightforward and easy. G of 5, I'm going to take g, which is log base 3, and all I'm going to do is plug in 5. So I'm hoping for that one. Nope. No luck. No dice. Okay. It looks like we have a whole bunch of change of bases possibly here. So as a change of base, this would be a logarithm with a 5 divided by a logarithm with a 3. So is there anyone where I have a log of 5 over 3? Yep, D. Look here. And then they chose 4. So log base 4. Log base 4. That's a change of base question with the evaluation. So D. Okay. Again, this idea of evaluation, remember, you can pause me and try these and then listen to the solution here. The function d is given by d of x is log base 2 of x. Which of the following is equivalent to the expression 3d of c plus d of r? College Board will throw in variables. Do not panic. Just replace the object as if it were a number. It's not a big deal here. So so 3d of c plus d of r. I'm just going to go ahead and replace stuff. So remember, d is log base 2 of x. So I get 3 times log base 2 instead of x. We have a c. And then plus log base 2 of r. And so looking at this, okay, of course we don't have that, but they do some manipulation here. So again, using my properties, hey look, I have that 3 out front. I'm going to use a power property there. So log base 2 of c cubed plus log base 2 of r. Well, hopefully you have c cubed times r. I'm getting b. Is that the correct answer? I got b. Yep. Okay. All right. Cool. Only a couple more here. Practice problem. Function q is the natural log of x. Which of the following is the value of 4 times q of e plus q of e squared? Go ahead, try this one, and then I'll go ahead and we'll look at the answers. Okay, so let's go ahead and look at this one. We have 4 times q of e, that's going to be the natural log of e, plus q, again, which is the natural log of e squared. Okay, well, this was pretty simple if you remember that that e is the log base e. That natural log is log base e, so these are inverses. These essentially cancel, so I get 4 plus natural log e, that cancels, I get 2. 4 plus 2, I get 6. 6, 7. Okay, did you get that? All right, we get 6. Okay, last two. Which of the following is equivalent to a times log base b of c plus d? Oh my gosh, man, this is a tricky one. This one is hard. So please pause me. I want you to shoot your shot. Pick A, B, C, or D. Try this. I'll talk about the answer here in a second. Okay, so this is difficult for the reason that they do some math magic here. The first part, though, you're going to be like, oh, I saw that coming. So log base b of c to the power of a. So I really like c to the power of a. So we have some good candidates. I don't know about c. I don't know about d because they have the plus sign in there. That seems like a common distractor. I don't know where they're getting the a on top of that d. But let's go ahead and see what else we can do. I have D here, okay, and what they do in order to get the answer is they just go ahead and multiply D by 1. If you multiply by 1, you're not really changing it. So how can I multiply this by 1? Well, I can multiply it by log base B of B. And another reason why they do this is, check it out, this is the same logarithm. So now if I have the same logarithmic base, I can add these. So log base B of B, remember that is 1. So I'm not really changing this. So if you haven't figured it out yet, pause me now and go ahead and see what you get. Okay, hopefully you figure this one out. Log base B of C to the power of A plus log base B of B to the power of D. And then we can multiply these. Answer? A. Answer was A. That was a tricky one. That's a real tricky one. Okay, and then here, I feel like you should be able to walk out of the door with this one. If you can't do this one, you need to go back and watch the last video and this one. Which of the following is equivalent? Pause me. Here's the solution. Let's go ahead and use our power property. D to the power of 4 minus natural log of y to the power of 2. Watch me get this wrong when I just said you need to go back and re-watch this lesson if you don't get this one. We're subtracting, so we're going to divide. So that's what I would expect to see. D to the 4th over y squared. I got D. D is the answer. Did I get it right? I did, according to my notes. There you go. Okay, so that is logarithmic manipulation, rewriting, finding equivalent expressions, all of those. So, do you know how to rewrite a logarithmic expression? Hopefully you know the power property, taking powers and putting them as coefficients or vice versa, coefficients to powers. And then what do I do if I'm adding two logarithms that are the same? You multiply them. What if they're dividing, or sorry, they're subtracting? You divide the arguments, okay? That's what you should take away. Catch you in the next one. See you later.